Okay, so it's still a pulsating DC voltage. So, VDC average. What is VDC average? It is the average voltage over one cycle of my input. Here's one cycle of my input. So on the output side, the equivalent is this area under the graph. Okay, over one cycle of my input voltage, VDC average is the area under the graph over 2 of the pulses. So that is 2 times V out peak over pi. In my half-wave one-diode rectifier circuit, I had V out peak over pi. Now it is 2 times that because of 2 pulses. So that's equal to 2 times 4.95 over 3.14. Which works out to how much? 3.15. So this is DC. This is what I would get if I connected a meter across the resistor. Okay. We'll finish off the other calculations on page 2. Let's go to page 3 and draw this circuit now, modified with a 200 microfarad filter capacitor connected across the load. So where do you think I would add the capacitor here in this circuit? Tell me. How would you, do I have a volunteer to come to the front? Yeah,
I'm not coming to the front, but I can say it.
Yes, what I'd say.
Would you need 2 between each center tab?
Nope. It is just across the load, just like before.
Oh, okay.
Yeah, so basically what you do is you take this resistor and you would go right across the resistor. Okay? So that's the circuit that we're going to draw, but I'm going to draw it a little different from that. So here's what I'm going to do. I'm going to show it a little bit different. So this is what I want you to draw now on page 3. On page 3, let's draw it a little different. It'll be exactly the same in terms of operation, but we will show it a little different. So first show your primary and your secondary. I'm on page 3 now. Show your center tap. Show your first diode at the top, second diode at the bottom. 1, 2, 3. But what I'm going to do is this. I'm going to go from my number 2 and I'm going to go outside like this. Connect these 2 together like I did there. And right at this point, instead of going inside to the minus, I'm going to come here, show my resistor outside, and it's still going to the center tap. So there's no difference between the 2 circuits other than showing them a little different. The reason why I do it this way is now I can show the capacitor a little nicer like this. are one and the same circuits. Yes.
Just wondering
No, because, look, here's the plus. Current coming in is plus, current coming out is minus. So when this diode is forward biased, the current is going to go this way into the resistor. That plus and that plus are one and the same. And then I come back to it. Okay, so that's why the plus appears at the top. So now, let's do the calculations. V secondary RMS, no change. Same as before.